Hello, Ryan here from RLF Vacuum Cleaners in Lakenheath, and in today's video we're going to be looking at some failed products, and more specifically JCC by Leviton products. Even got a fancy box. We have 16 LED downlights that are all dead. I picked these up from David Savory from David Savory Electrical Services. I'll make a funny picture of him appear here somewhere. David's already made a video about this, quite an interesting video where he puts the boot to Leviton on JCC and any other manufacturer crap LEDs. So I won't be getting too much into the detail of that because he's already made a good video. Link or picture or make something happen here, and there'll be something in the description and probably one of them tag things in the corner or something will happen. That's future Ryan's job anyway. It's so nice of you to think of me. So what we're going to do is we're going to investigate why these failed. Hopefully it's nice simple faults, but it might not be. I haven't actually done any filming yet, so who knows. So what I'm going to do is I'm going to pass these on to future Ryan and he can pick up from there. So here we are. How are future Ryan? Oh, thank you, past Ryan. I'll take it from here. Now, before we start getting too technical, I'm no electrical expert. I'm just a guy in a shed with some electrical gear, soldering iron, multimeter, basic tools, just bambling my way through, seeing if I can find some faults with them. So to start off the video, I'll just remove the cable from one of these destroyed boards. You can see that's completely destroyed and beyond repair, so we won't be doing anything with that. So I've taken the cable off so I can plug in these V50s up to my DC power supply, and we'll test all of these. I've got a box with them, we'll test them all. Because with LED failures, you often do get quite a few failures of the LED chipsets dies themselves. So we'll check all of them to make sure they're all good, and then after that we'll start cracking open the drivers and seeing what's going on. Hopefully we might find one or two dead light unit, spotlight, downlight unit thingies, and then we can have them apart and have a look at them. So we'll go from there. Now, these LED spotlight units are constant current. So the older ones, they run at 310 milliamps, and the newer ones run at 175 milliamps. Basically what happens is these drivers, they put out a range of voltages. So what happens is they will constantly put out 175 milliamps, and the voltage will fluctuate to deliver that 175 milliamps. So if I set my DC power supply, say 300 milliamps, it should be plenty enough to illuminate these LEDs, and we'll see what happens. So we'll just connect that one up. You can see that's on. Now I won't bore you with doing every single one, but I will come back if I find one that is not working. These are all the LED downlights tested, they all work. I got them running at sort of a lowish current. You can see they all light up and I can't see any. I don't know if the camera can pick it up, but there's no like dead LED chips in them. So all these JCC downlights, the actual LED part of them works, which means all the drivers have failed. Which would be brilliant because you know you've got these plugs on them, quickly change them, but I'm reliably informed that you can't actually buy the drivers separately for them. It's such a waste. You've got this good quality product. Future Ryan here. When I say good quality, I mean the product isn't good, it's shit, it's JCC. All about the fact that they've designed sort of a semi-decent LED light in can bezel where none of the LEDs have failed, where everything else has failed around it, but the LEDs seem to be alright. It still works, just dead because of the driver, which is a separate part, which they don't sell separately. So yeah, well done JCC. But anyway, we'll clear all this out. We'll bring a couple of driver boards in, give them a quick test and quick once over, and we'll see what we'll find. See, here we have one of these driver boards out of the JCC V50 downlights, and to be fair, from the outside it doesn't look too bad. There's no sign of thermal degradation anywhere. Everything looks reasonably well soldered. I can't see any issues as such. So we'll do the standard basic checks, which will be these things here. They're using a PCB track as a fuse. So I'll stick my multimeter probes on and we should hopefully get resistance. Yeah, that's good. And then we've got two 100 ohm fusel resistors before they go into the bridge rectifier. So we'll see. I'm trying to let this RS Probe IDM 72 multimeter today. And you can see, get 100 ohms on that side. And I get 100 ohms on this side as well. Right, just a quick update. I've been sort of gently probing around the board, looking at individual components and other things like this. And one of the things I've come across is, because I've actually picked up a good board, this actually driver board actually works, so I can sort of cross-reference between what values are on the good board and what values are like on some of these bad boards. And one of the things that I've noticed is, we've got on diode, I've got my special tweezers, and what we'll do is we'll just probe across this camera's not going to focus, is it? We'll just probe across this diode here, because on the good one we're getting no normal diode values, we're getting about 0.5 volt drop across and nothing across the other way. On this particular one, what we'll do is we'll probe the diode like so. So we're getting about 0.49, which is about right. But then if we flip it over and go the other way, we get about a 0.85. Oh, you get about 0.8, 0.9 volt drop. So could that be the issue? Because if you do the same thing on this good board, probe across this diode, we're getting nothing that way. But then when we flip it round, we're getting about 0.6 volt drop, which 0.5, 0.6 volts is probably about right you'd want for a diode, but it's not conducting the other way. So that leads me to believe, focus, is either we've got a faulty diode or something in this chip packed up and causing us to get a funny reading. Now, the easiest thing to do is, if we remove this diode quickly, probe across, see what we're getting. If we're still getting a weird diode reading, we'll know it's a chip or somewhere else to look. And we don't really want to be removing the chip. We'll start off with removing this diode and we'll go from there. Now, I don't know if I got any diodes in this particular package. I suppose worst comes to worst, we can always find another diode or something, just jerry-rig something to see what actually happens, see if it works or not. So yeah, I'll get this diode off and I'll be back in a moment. Just to prove we don't need any fancy tools, I'm just going to use my cheap £2.50 Duratool soldering iron from CPC and just a cheap pair of tweezers I bought from Parkside ones I got from Lidl. So in fact the total cost of the tool, obviously stand is optional, but I recommend a stand, it's going to be a few pounds, and then diode going to be a few pence. So realistically, if you want to get involved in electronics and do what I do, you don't need to spend that much money. You could probably get a decent setup for £50 or less. I'll make a video about that at some point. So I'm just waiting for the soldering iron to heat up and I'll be back in a moment. Alright, so we've got the diode removed and we'll just probe across. As you can see, we've got nothing that way. And if we flip it over, we've got nothing that way. And then if we just zoom in, there's actually a diode and you can see how absolutely tiny it is. So if we just stick that on there, if we probe across there, we get about, say, 0.9 that way. And if we flip that over, whoop, we're getting, yeah, about 0.4 that way, so that diode is definitely faulty. So we'll have a look, and we'll see what diodes we got. I think we've only got generic standard 1 amp 1000 volt diodes, so we'll see what we got. We'll put the new diode in and we'll see what happens. Back in a mo. And we're back again. We've managed to chunkily put in a new diode, and we're going to give it a quick test, see what happens. So we've got the repaired board with the new diode chunkily put on there, but it's good enough. I can compare this next to the good one. So, the good one, nice and bright. Where the repaired one, it is actually working, but it's not very bright. If I can bring in the multimeter, we'll see what output voltage we're running at. So back in a moment. We're just probing across the output. We're getting 31 volts, which is a bit on the low side, because they're rated at about 36 volts. They should be outputting about 36 volts, so obviously the constant current driver bit's obviously not working as it should. Now unfortunately I couldn't find any information on the data sheet for that particular switching chip, so I wonder if there's a capacitor or a resistor or something that's not quite set to the right value. It might even be that diode. That diode might not be the most optimal, but we'll keep investigating, see what we can find, see if we can make that light brighten up a bit. So yeah, partial victory. Back in a mo. And we're back again. Having been over this board very thoroughly, taken bits off, testing it, resoldering some joints and things like that, we still haven't been able to make it any better. So unfortunately that leaves us with the one thing I didn't want to do, is remove this chip here, switching chip, from this good board, swapping it with this one here and seeing what happens. This could end with me fixing it, or more likely it could end in a disaster where I destroy this chip, which I don't actually know what it is. I've only got one of these good chips, or one of these good boards, and loads of dead ones, so yeah. We'll carefully remove this one, carefully remove that chip, swap the chips over, using my hot air station. You can see, put a new chunked a new diode on, and when we give it some power, you can see it lights up, no flickering, it's nice and bright. I'll grab my watt meter in a minute and we'll see how much power it's drawing. But yeah, it looks like all it is on some of these is just the diode. On the, I'm guessing the diode is part of the feedback circuitry, and for some reason it just stopped the light from working. So yeah, a few pence for a diode, solder it on, lights up and running again. So what I'll do is I'll do a few more. There aren't a few of them, like this one here. I've put down bridge rectifier and fuse. When I say fuse, I mean these two resistors here are open circuit, and the bridge rectifier is giving funny readings. I haven't checked the diode yet. I'll check them as well. They might have the same issue, but they might be a different issue. But yeah, so far we've either got bridge rectifier or fuse. Where's the other one? This one here labelled IC again, which I think will be that diode again. This is the one from the David Savory video, the one he destroyed. Unfortunately, it's a bit too far gone. It sort of delaminated the track, so I'm not going to repair that one. So I'm guessing that one probably had a bridge rectifier failure. So yeah, I'll do a few more. I'll update you when I'm done. That's what I got here. So I got a couple more with these diode issues. So I'm going to grab another donor diode, a couple of donor diodes. I'm actually stealing them off this bridge rectifier off another circuit board. Because probably I can't find any diodes, service mount diodes that small. For using these ones are a bit too big, but they'll do just to prove a point. So yeah, I'll get them diode number ones there swapped over, and we'll come back when they're ready to test. That's these two boards done. Jerry rig new diodes on there. So we'll just fire them up. as you can see, the new diodes fixed it. Light's now on. Having a bit of research on them diodes. Then they're not the best rated for this application. They're only rated at 100 volts. And I think realistically, again, we're running around sort of 100 plus volts. So push them a bit to the limit. That's probably why they failed. But yeah, here we have a couple of more downlights fixed. Now what we're going to do is I'm going to research and I'm going to find a more suitable diode to take over the position of these ones, just so I can fit these in my house and actually prove, or fit them somewhere and actually prove that my fix is reliable. So yeah, on to the next ones. The more suitable diode I'll be using will be this 1 amp 400 volt diode. So what I'll do is I'll quickly do a quick sped up of changing one of these over. So yeah, to the overhead view. So future Ryan here, just doing a quick swapping this diode over. So just using the soldering iron to sort of gently heat up each end, and then using the tweezers to pull it off, like so. So we'll grab the new smaller higher rated diode, which is absolutely minuscule. I don't think the camera does it justice how small this is. The actual width of the tweezers is actually too big, so you can't actually slot it in there lovely. So it is a bit of a faff to try and sort of get it into the right position and sort of get one end in, and then sort of put some fresh solder on each end, and then hope it doesn't point out too badly, but we'll use the hot air gun to straighten out later. So we got that on there roughly. Going to put a bit of flux on, each end like so, and then sort of gently use the hot air gun to sort of gently warm it up, and then use the tweezers to manipulate it into place. So as you can see, it's starting to melt now, and the sort of solder's sort of pulling it away. So use the tweezers, gentle push, hold it in position, let it cool down, and ready to go. On the boards we mark BR plus fuse. That's when we done a quick measurement. We found the fusible resistors are blown, and the bridge rectifier was giving a funny reading. Now we're taking the old thermal fusible resistors out. We put a new bridge rectifier on, but the fault's still there. So what we done was we grabbed another one. It was on the original bridge rectifier, but we took the main chip off, and the fault has cleared. So obviously these bridge rectifier and fuse ones, obviously something inside the chip has failed, causing it to blow the thermal fuse. I'll bring in my multimeter quickly. If we go there to there, we get a 1.7 volt drop. If we do the same thing on the other one, so on the other one where the chip has been removed, open circuit. So whatever these chips are, there is a number on them, but unfortunately it doesn't cross to any data sheet or anything like that. So unfortunately, I don't think these boards will be fixable, even though that the diode which we replaced on the other ones, that one's faulty as well. So yeah, unless we can find the source for them chips, I don't think there's going to be much we can do with these boards, but we'll have a try. So we'll move on to the FG LED ones now. Now moving on to these FG LED downlights. These ones have a very weird issue where they'll run for a few seconds and then they'll turn off. This one gonna do it? Yeah. They run for a few seconds and then they sort of slowly die off one by one. It's almost as if the circuitry inside restarts. So what we'll do is, we'll disconnect it. We'll disconnect everything. This one here, you've got to unsolder the circuit board to get to all the important stuff on the bottom. This flickering you see on camera, I can't see this This is what the camera's picking up. Is it going to do it anymore? It's a weird one because you can have it running for sort of 4 or 5 minutes and it didn't do it, and all of a sudden it'll just flash, 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 and it'll stay off for a little while and it'll flash. It's a right pain in the ass. Second I stop the camera it'll start playing up again, but yeah, that's what it does. It sort of randomly flashes and turns off and doesn't come on, and yeah, it's a weird one. To save this video being horrendously long, I'll just point out what I found wrong with these FG downlights. Just re-watching that video back, currently doing some editing, I don't think it was them diodes that were at fault. I think it was the solder joints on the connector, because looking back at the video, some of them did look rather rough and not very good, so I wonder, in the process of taking it apart, putting them new diodes in, I've actually inadvertently fixed the fault by the fact that I've taken them off and then resoldered them on and done a reasonable job resoldering them on. So I actually think the fault was some joy joints or not very good connections being made between the board and the LEDs. Just an observation I found. I'll let you carry on. What we found was there's actually a diode under here. A lot of these diodes were giving funny readings. So to replace one of them, it's nice and simple. You just undo the 2 screws, desolder this connector here, pull the board off, flip it over, take the diode off, new diode on, plonk it back on, solder it back on, screws back in and test it. So I'll get you to the overhead shot and I'll show you doing that. So here we are, future Ryan here. We're just going to go through this. So we're just unscrewing the 2 screws like so, top and bottom. Going to bring the soldering iron in, put a bit of fresh solder on each one, gently rub it across each of the connectors and wiggle the board till it comes off. Flip the board over, give it a quick focus like so. And a bit of solder on each of the end of the diodes like so, a bit of fresh solder, gently tap the iron across like so until it pops off. These are wave soldered, so they're actually glued on and then they go through like a big fountain of solder. That's how they're on the board. Bit of solder wick, so I give the pads a bit of a clean up. Then with the new diode, drop it on like so. Tack one side on, like so. Fresh solder on each end. Hey presto, we're all done. So now what we have to do is reassemble it. So what we'll do is we'll get some solder braid, gently clean up the connectors on the light, like so. Just get the worst of the excess solder off. Then we'll place the board on the top. Gently warm them up and push down as we go to get the connector to slide back on. And then we'll just put a bit of fresh solder on to finish it all off. Easy peasy, all done. So that diode replaced, we'll quickly turn on and see what happens. We have to ignore the flashing, it's just the camera picking it up, it's not actually strobing in real life. But it seems to be going alright. We've got no turning on and off, so I reckon that diode must have fixed it. But we'll leave it running for a little while and I'll update you if it starts flickering. And we're back in. This FG downlight's been running for about half an hour or so and it hasn't flashed on and off or given any issues. The flashing you can see is what the camera's picking up. I can't actually see any flashing. So yeah, all the FG downlights we had, I replaced all them diodes and it seems to have fixed them all. So to conclude, here we have all the boards. So we've got 10 boards here. We've got 4 FG LED and 6 V50 boards that we have fixed. These ones here are all diodes. Now these 4 here, I did put new diodes in, but I don't know if I mentioned in the video or not. I suspect it probably wasn't diodes that were the issue. They might be. They were giving funny readings. But I think it was more likely, watching back when I was editing the video, that these had dry joints or loose joints. And then the process of me removing this board, taking it off and resoldering the joints, I think that fixed it. But they're all working now, I can't fault them. And then we have these 6 boards, 6V50 boards here, which I suspect are all chip failure, because they're all gone bang quite badly, you know. The fusible resistors are all gone. Oh, that one is completely melted. I suspect it's probably the bridge rectifier, but as I mentioned earlier in the video, that when I put a new bridge rectifier in, the fault was still there, but when we removed the chip, the fault went. So unless I can find a new one of them chips, which is finding quite hard because none of the usual suspects have it, if I can, I'll make that picture pop up on the screen somewhere here, and if anybody can find one of them chips in sort of a reasonable quantity, you know, I got 6 broken boards, although I think it's this one, yeah, that one there is fairly well damaged and delaminated, so if they come in packs of 10, that ain't too bad of a problem, because I got 5 boards that could do with them chips really. But you know, 6 out of 16 failures isn't too bad. Got 10 working lights, so yeah, I hope you've enjoyed watching this video. It's been a very long video for me to make. It's also involved quite a lot of physical money, buying parts and time and other expenditure. So yeah, I hope you enjoyed this video. Like, comment and subscribe. Not really, do what you like, I don't care. So yeah, I wish you a good evening and see you again sometime.